In this video, I'm going to show you how to render VDB holdouts using Movie Render Graph in a real engine. Rendering VDB holdouts is extremely useful because it allows you to isolate volumetric effects like smoke, fog, and render them separately from the rest of your scene. This gives you much more control in compositing, letting you fine-tune lighting, shading, and VDBs itself without interference from other scene elements. In my case, I had to learn this out of necessity. I was working with 4 different VDBs in the same scene, all with shadow casting enabled, and I started running into shadowing issues that simply couldn't be fixed unless I removed at least 2 of the VDBs. Rendering them separately solved the problem entirely, so this workflow can be a real lifesaver in more complex setups. First, we need to make sure that the Movie Render Queue plugin is enabled. When that is done, open your sequencer, click on the Movie Render Queue icon. From here, we need to convert Movie Render Queue into Movie Render Graph. By default, Unreal gives you a read-only render graph, so we'll need to create a new one. Create a new Movie Render Graph, place it in any folder you like, and name it however you want. I'm not going to focus on folder structure or naming conventions in this video. Now, select the newly created Movie Render Graph and double-click to open it. If this is your first time here, it might look a bit intimidating, but there is nothing to worry about. Each node in the graph directly corresponds to settings you normally find in Movie Render Queue. At the top, you'll see global output settings, where you can control things like output directory, resolutions, playback range, and other familiar options. Below that, you will find the render node. By default, this is how the fair render, but you can also switch to path tracer if needed and access all the related settings here in the detail panel. Next is the file format node. I'm going to choose a PNG sequence, but you can also choose a JPG or EXR depending on your needs. Now we're going to add a collection node. This collection will contain all the actors that will act as a holdout. Make sure you name this collection, especially if you plan to use more than one. If collections aren't named, Movie Render Graph will only consider the last one in the chain. Next, add a condition group. This is where you define which actors from the scene belong to the collection. There are multiple ways to do this, by actor name, layer, tag, or folder. For example, I'll use the basic actor selection method. Instead of manually selecting everything except the VDB, I'll go to the viewport, select the VDB in the outliner, then invert the selection, then go back to the graph and click Add Selected to Outliner. This automatically adds all actors except the VDB to the collection. Now that the collection is set up, we need to tell Unreal what to do with it. So add a modifier node and name it as well. In the modifier settings, assign the collection we just created and enable holdout. At this point, if this is the first time that you do this for this project, Unreal will prompt you to enable the support primitive alpha holdout. Click enable and then restart the engine. Once the project is reopened, we can add the final node, which is going to be the render layer node. Connect it to the default layer and rename it from beauty to holdout. That completes our render graph, so go ahead and save it. I just realized I forgot to add a camera to the scene and to sequencer, so I'll quickly do this. Also, you need to make sure that you are still in the movie render graph. As we restarted the project, it probably switched back to movie render queue. So click the down arrow and select movie render graph and select also the newly created graph. Now hit render. You should see Unreal rendering only the VDB with a transparent background while the rest of the scene correctly acts as a holdout. Notice how other objects partially occlude the VDB. This makes recompositing incredibly clean and flexible. This workflow is extremely powerful, especially when dealing with complex volumetric setups. I hope you find this useful and thanks for watching.